In this episode, we're going to talk about a part of networking that often stays invisible until something goes wrong. The big roads that carry data between places and the organizations that decide how that data gets routed. In OT, people tend to focus on plant networks, controllers, and the boundaries between operations and business systems, because those are tangible and close to the machines. But modern OT environments are rarely one isolated site anymore, and many organizations connect plants, remote facilities, and vendor services using private wide-area networks, dedicated backbones, and internet routing that depends on decisions made by many independent networks. When those connecting layers are stable, nobody thinks about them. When they fail or get abused, the impact can look like a sudden loss of visibility, broken remote support, delayed alarms, or inconsistent access across sites. Our goal is to build a beginner-level understanding of what privatized backbones are, what autonomous systems, AS, are, and how those choices affect security and resilience. We'll keep this grounded in practical consequences rather than deep routing math, so you can reason about risk even if you have never configured a router. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series. A good starting point is to clarify what a backbone means in everyday terms. A backbone is a high-capacity network path designed to carry large amounts of traffic across long distances, connecting smaller networks together. In a company context, a privatized backbone is a backbone that is owned, leased, or managed for a specific organization or group, rather than being the general public internet that anyone uses. This can include dedicated fiber links, carrier-provided private networks, or managed wide-area services that create a private path between sites. Organizations use privatized backbones because they want predictable performance, better control, and sometimes stronger separation from the public internet. In OT, that predictability can be important because plants may need stable connectivity for monitoring, reporting, and coordination, and they may have limited tolerance for random internet congestion. But private does not automatically mean safe, and predictable does not automatically mean resilient. The security and resilience impacts depend on how the backbone is designed, who operates it, and what other systems depend on it. Now let's define autonomous system, AS, because it sounds abstract, but it's actually a simple concept with big consequences. An autonomous system is a network or group of networks that is operated by a single organization and presents a unified routing policy to the rest of the internet. In other words, it is one decision-making domain for how traffic should flow in and out. Internet traffic moves across many autonomous systems because your organization's network, your internet provider's network, and cloud provider networks are all separate domains that exchange routing information. The mechanism that helps autonomous systems tell each other where to send traffic is Border Gateway Protocol, BGP, which is like the internet system for sharing directions. You do not need to memorize protocol details to understand the security point. Routing is based on shared announcements of reachability, and the correctness of those announcements matters. If the announcements are wrong by mistake or by malice, traffic can be misrouted, intercepted, delayed, or dropped. For OT environments that rely on remote connectivity, that can translate into real operational disruption. When organizations talk about privatized backbones, they often mean they are trying to reduce reliance on the public internet's shared and sometimes unpredictable nature. A private backbone can reduce exposure to certain types of attacks that happen on public networks, and it can reduce the number of unknown intermediate networks that traffic crosses. It can also improve performance and reduce latency by using optimized paths. For example, a company might connect multiple plants with a dedicated wide-area service that avoids general internet routing for most internal traffic, that can support centralized monitoring, consistent policy enforcement, and more reliable remote operations support. However, the trade-off is that concentrating traffic into a dedicated backbone can create a strong dependency. If that backbone has a failure, many sites can be affected at once. It can also centralize the places where attackers might focus, because a backbone often becomes a high-value target for disruption or observation. Beginners should carry the idea that privatized backbones can reduce some risks, but can also increase the impact of other risks because of dependency and concentration. A major resilience concept here is the difference between redundancy and diversity. Redundancy means you have backups, like a second link or a second provider, while diversity means the backups are meaningfully different, so they do not fail in the same way. A privatized backbone might be redundant inside itself, with multiple links and automatic rerouting. But if all of those links share the same operator, the same management systems, and the same policy control, then certain failures can still take everything down at once. Diversity might mean using different physical paths, different carriers, or different technologies so that a single fiber cut, a single provider outage, or a single management error does not isolate multiple sites. In OT, diversity can be especially valuable because remote sites may have limited local support, and connectivity loss can delay incident response. But diversity can also be hard because it adds complexity and cost, and complexity can create its own failure modes. The balanced beginner understanding is that resilience is not only about having two of something, but about whether those two things can fail independently. Let's talk about BGP-related risks in a beginner-safe way, because the internet has a long history of routing mishaps that range from accidental to malicious. One risk is route leaks, where routing announcements that were meant to stay within a certain scope accidentally spread more widely, causing traffic to take strange paths. Another risk is route hijacking, where a network announces that it can reach an address range it should not control, potentially drawing traffic toward it. These events can happen due to configuration errors, misunderstandings between networks, or intentional abuse. The impact can be loss of availability, because traffic stops reaching the correct destination, or loss of integrity and confidentiality, because traffic might pass through an unexpected network where it could be observed or manipulated. For OT workloads that depend on cloud services, remote monitoring, or vendor support, a routing event can look like a mysterious outage that is hard to troubleshoot from the plant. Even if the plant network is healthy, the path to a service might be broken upstream. Beginners should learn that the network is down can mean the path between networks is wrong, not that any one local device has failed. Privatized backbones can reduce certain BGP exposures if traffic stays within private routing domains for internal communication, but they often still touch public routing at the edges. If your backbone connects to cloud providers or external services, those connections may still depend on public interconnections and routing agreements between autonomous systems. Some organizations use private interconnects or dedicated links into cloud providers to reduce public exposure, but those still rely on correct routing and correct policy at multiple points. The big idea is that connectivity is an end-to-end property, and every segment of the path matters. In OT, connectivity is not just about convenience, because it can influence how quickly you detect problems, how fast you coordinate response, and how reliably data arrives for decision-making. If your visibility depends on paths outside your control, you need plans for what happens when those paths behave badly. A beginner doesn't need to configure routing, but they do need to understand that external path risk is a real part of operational security. Security impacts are also shaped by who manages the backbone and what access controls exist on the management plane. A privatized backbone might be managed by the organization itself, by a telecom provider, or by a managed service provider. In all cases, there is a control system that configures the network, monitors it, and changes policy, and that control system is often reachable through administrative interfaces. If those interfaces are compromised, an attacker might reroute traffic, disable links, or degrade service in ways that are difficult to diagnose quickly. In OT contexts, this can be especially painful because degraded connectivity can isolate sites just when coordination is needed most. Another risk is insider or contractor access misuse, where legitimate access to the backbone is used improperly. This is not a reason to avoid managed services, but it is a reason to demand strong controls, clear identity management, tight permissions, detailed logging, and strong change approval processes. Beginners should remember that the backbone is not just cables. It is a managed system, and managed systems are vulnerable when management is weak. Resilience impacts show up not only as total outages, but as partial failures and performance degradation. A backbone might still be up but congested, causing delays and packet loss that break time-sensitive monitoring or remote access sessions. A routing change might send traffic through a longer path, increasing latency and making some applications behave unpredictably. A failover event might shift traffic to a backup link with less capacity, which might be fine for basic communication but not for high-volume data transfers. In OT, these subtle changes matter because operators may rely on consistent trends, stable remote visibility, and predictable response times during incidents. A security system that depends on cloud analytics might appear quiet, not because nothing is happening, but because data is delayed or dropped upstream. That can create a false sense of safety. The beginner lesson is to treat performance and reliability as security relevant in OT, because an attacker's easiest win is sometimes to disrupt or degrade, not to steal. It's also helpful to understand how privatized backbones interact with segmentation, because organizations often rely on the backbone to enforce separation between sites or between business and operations domains. A private backbone can be designed to carry multiple separated networks over the same physical links, with policies that keep traffic isolated. That can be efficient, but it depends heavily on correct configuration and change control. A misconfiguration in the backbone can accidentally bridge traffic between zones that should be separate, which in an OT context can create pathways for threats to move. Conversely, a well-designed backbone can strengthen segmentation by providing consistent policy enforcement across sites, reducing the chance that one plant is configured differently than another. This is one of the reasons modern network management is attractive, because consistency reduces human error. But consistency also means mistakes can be consistently applied everywhere. Beginners should hold both ideas at once. Centralized control can reduce random drift, and centralized control can amplify mistakes. Another important angle is incident response and recovery. When connectivity issues occur across multiple sites, teams need to decide whether it is a local issue, a backbone issue, a provider issue, or a routing issue across autonomous systems. If you do not have visibility into the backbone, you may waste time troubleshooting plant switches and firewalls that are working perfectly. If you have visibility but no authority to change provider-controlled systems quickly, you may be stuck waiting for external action, which is a resilience concern. Many organizations build runbooks and escalation paths specifically for wide-area outages, with clear criteria for when to shift to backup links or when to switch to local-only operations mode. In OT, local-only mode can be the difference between safe, continued operation and an unnecessary shutdown. A beginner should learn that good resilience planning includes communication plans, fallback procedures, and clear ownership, not just technical redundancy. Finally, we should tie these concepts back to why this topic belongs in an OT security certification. OT security is not only about preventing malware or blocking intrusions. It is also about ensuring that the systems supporting safe operations remain dependable under stress. Privatized backbones and autonomous systems influence that dependability because they determine how sites connect, how traffic is routed, and how quickly teams can see and respond to problems. Security impacts include the risk of misrouting, interception, and management plane compromise, while resilience impacts include dependency concentration, shared failure modes, and performance degradation that can hide problems. A mature evaluation asks which workloads truly need wide-area connectivity, what happens when that connectivity is impaired, and how to preserve safe operations when external paths fail. If you can explain the difference between private backbones and the public internet, describe what an AS is and why routing decisions matter, and connect those ideas to availability, integrity, and recovery, you will have a strong foundation for understanding how networking architecture shapes both security and resilience in modern OT environments.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.